Previously on What is Probability? So last time we talked about a big graph and we had a trainer, and over a certain number of sessions people were getting more and more baskets in a row, and these were all bubbles representing people. So each of those dots is a person, what session they're on, and how many baskets in a row they can make. And we noticed that it was following a very clear progression. There was a nice linear progression there. And so we came up with the formula for that, and we had to use the calculator to do that. The calculator did its magic, and we found y equals mx plus b from that. Notice our b, our y-intercept, is at the start. So before any sessions happen, this is about how many baskets people can shoot. Our slope, or our m, is the rate. So for each session, how much would they improve? We then talked about what this line actually means and how we can use it to predict things. Interpolation is when we're predicting something inside the data. So I am not inside the data. I have not trained with this trainer, but I can tell by the line approximately where I would be around session number 13. Extrapolation means I'm following the trend. So in this case, there are no bubbles that are that far ahead, but one of the bubbles is getting pretty close. So if they follow on the same line, that's approximately where they will be 3 sessions from now. And finally, we have our outliers. This person is not near the rest of the population. Those are the weirdos of the weirdos. They are not near the line. They are not near the other bubbles. They are outliers. What is Probability? Episode 9, Relationships. Illustrated and narrated by Izzo. Okay, so we're back at that graph. Now what are we going to do with it? Well, we talked about how all of the dots are pretty close to the line, except for that outlier. Well, based on how close those dots are to the line, that will tell us how good the line is at being an average. If all of the dots are really close to the line, that means the line is a very, very good prediction of what is happening. So we call that tight to the line is a nice strong relationship. Now, instead of using the word relationship, mathematicians developed the word correlation. So we call it a very strong correlation, very strong relationship between the number of sessions and the baskets that people make. That's what happens if all the dots are really tight to the line. What happens if the dots are further away from the line? If that outlier is pretty much everyone? Well, that means if they are far from the line, we have a very weak relationship. It is no longer a strong relationship. The line isn't as useful. We call that a weak correlation. Notice, in this case, the number of sessions, as they increase, the number of baskets increase. This would be considered a positive relationship, or positive correlation, because as one goes up, it brings the other up. It's also a moderate correlation because the dots are close to the line-ish. They're not right tight to the line, but they're not willy-nilly all over the place. What happens if I turn the graph? In this case, as the sessions increase, the baskets decrease. This means the trainer is actually hurting the people. This would be called a negative relationship. If as one gets better, the other one gets worse, it brings the other one down, that is a very negative correlation. So it's still moderate because the dots are still the same distance from the line, but in this case it's negative. So because of this, mathematicians have decided to come up with a whole big spectrum. They start with a positive strong correlation. As one goes up, the other goes up. This would mean homework versus grade. If you do almost zero homework, you're going to get a grade of almost zero. If you do all of your homework, you're going to get a fairly good grade. That would be a very strong correlation, and it would be very positive. As one goes up, the other goes up. A more moderate correlation is seen with music versus grade. Those people who tend to be more musically inclined tend to have better grades. So those people who are working on music tend to have better grades. Is it exact? Well, not as exact as homework versus grades, but still, as one goes up, it lifts the other one up. Then there's no correlation. No correlation would be something like birthday versus grade. The people born in January, not going to be a better grade than the people born in June. That's not how that works. Birthdays and grades do not have any relationship at all, so we call that no correlation. Then we have a negative moderate correlation. So as you see, the dots are closer to the line, just like the positive moderate correlation. But in this case, as one gets bigger, the other one gets dragged down. This would be something like video game time versus grades. Now, if you're playing about 4 hours of video games a night, yeah, it's possible you'll still wind up in the 90s. However, if you're playing 10 or more hours a night, your grade probably suffering. And then we have a negative strong correlation. This one is very clear and very obvious, like skipping class versus your grade. If you skip a whole bunch of classes, then yeah, you're not going to have the material and your grade is going to suffer. So it's a very strong correlation because one very much impacts the other, but it's negative because as one goes up, the other one is dragged down. So this is our spectrum, and we call correlation by R because it's our relationship. So our relationship goes all the way from -1 with a negative strong correlation to +1 with a positive strong correlation. And in the middle, we got no correlation whatsoever. At the ends, we have very good predictions. So it's a good prediction skipping class versus your grade and homework versus your grade. Those have a big impact on your grade, so once we've gotten the trend, it'll be a very good prediction about where you would land. Whereas something with no correlation is going to be a very bad prediction. Yes, I could fit a linear regression to this. The calculator will calculate out a line for you. Unfortunately, it will be absolutely useless. Okay, so now we're back with this, and we've got beach time. This is my favorite example. Love this example. We've got ice cream sales and number of people drowned. Okay, well, this was actually a real study. The data isn't real, but it was a real study. They looked at ice cream sales on beaches and the number of people drowned each year, and they found that the more ice cream was sold, the more people drowned. Which, you know, sounds cruel. But they got that it followed the line, and it was a very positive, very strong correlation. As one goes up, the other goes up. Everything was very tight to the line. So, how do we explain this? How do we explain that ice cream sales going up makes number of people drown going up? Well, that's the difference between correlation and causation. Two very, very close words. Causation is that one variable causes the other to increase or decrease. So homework and your grade, that would be causation, because homework causes your grade to increase or decrease. But in this case, it doesn't seem right. It doesn't seem like ice cream sales would cause people to drown. I mean, these are just sales of ice cream. We don't even know if the ice cream's being eaten. We don't know who's buying the ice cream. Maybe because people drown, that's causing people to buy ice cream. But that doesn't sound right either. In fact, this is a very strong correlation because both of these variables are caused by something else. Correlation just says that the variables are related, which means they could be related through a third variable. In this case, it is temperature. They are not causing each other. They are correlated. The lower the temperature, the fewer ice cream sales and the fewer people on the beach. So the easier it is for the lifeguards to see who needs help. However, as the temperature rises, ice cream sales rise because it's hot. And the more people at the beach, because it's hot, means it's more difficult for the lifeguards to actually see what's happening and to rescue the people who need help. So it's the temperature that's causing the ice cream sales and the number of people drowning, which means you have to be very careful when talking about statistics. Sometimes two variables are very related, but they are not causing each other to happen. Let's talk about something that is caused. So, positive strong correlation. This time we're talking about health. And we've got cigarettes smoked, and we've got lung cancer. So, the more we smoke, the more lung cancer there is. Correlation versus causation. Well, after decades of study, we have figured out it is a causation, that cigarettes cause lung cancer. That yes, everybody knew they were related. It was really easy to prove that they were related, but could they be related through something else? Could another lifestyle issue be causing both things? It took decades to determine that cigarettes cause lung cancer. Just because it was so hard to put together an experiment. All people could do were observational studies, so all they could do is sit and wait and watch and see who dies and what they die of. So, why did it take so long? How did they figure out it was causation? It was a grueling process, and one that vaping now has to undergo. The population is all of humans. So all humans, all ages, all races, all lifestyles, all humans are a population, which means that sample, when we take that sample, it has to be representative of everyone, which is extremely hard. And then we can't do an experiment on it. We can't force people to vape. All we can do is watch and see if the people who vape die and how fast they die and what they die of. It will be a very difficult process. But good news, the people who are dying are stupid enough to vape. So really, what are we losing? I'm sorry to all the vapors out there. Actually, I'm not. I mean, to be fair, it's obvious, vaping bad. Okay. What happens if we have data that doesn't follow a line? So in this case we've got one variable, it might be causing another or it might be related to another. But if you notice, it doesn't follow a line. It does follow a pattern. It follows a very clear swooping pattern. but it does not follow a linear pattern. That is what we're going to be learning next session. Stay tuned.